How are you all? I hope you all are doing well. We have started lecture series on multiple competitive exams like NET, CET, GATE, CET, JEE, and Mains and Advanced. So from few days, I started solving JEE Advanced previous year question paper. So as I solved multiple questions, I found these questions are easier to solve, but just we need to know some of the basic concept and we have to think little more, okay, to solve this question. It is not that difficult, so we can solve this question very easily. So in my today's video, I will go through some of the question from JEE Advanced, okay. So now let us see the question what we have here in our today's question. So in our today's question, we have given matrix, okay. Our today's question is completely based on a determinant matrix chapter, okay, that we need to know how to find inverse, how to find determinant, and need to apply some of the basic trigonometric result, okay. So now let's get started our today's solution question. So our question, it says that we have matrix 2 by 2 matrix given, M as a 2 by 2 matrix, sin raised to 4 theta, second term minus negative 1 negative sin square theta, 1 plus cos square theta, and cos raised to 4 theta, and which is equal to alpha I plus beta into m inverse, okay. So this is the value for m, which is equal to alpha I plus beta m inverse, where alpha is given alpha of a theta and beta is given beta of a theta. Why it is given? Because these are the form like a theta form numbers, okay. They are from theta like numbers and all belongs to real number, okay. And here I is a 2 by 2 identity matrix given, and that alpha and beta, okay, by using that alpha, they have given here alpha star is a minimum of the set alpha of a theta, which is equal to form theta belongs to close 0 to pi. So that means alpha of a theta we can take it here from 0 but not 2 pi, okay, from 0 to 2 pi but not 2 pi, but 0 included here. And similarly for beta star also given, minimum value for beta star is a 0 to 2 pi, but 2 pi it is not included, okay. And using all our given data, we have to find out the value for alpha star plus beta star, okay. So we want the value for alpha star plus beta star. So in order to get the value for alpha star plus beta star, we have to define first of all matrix, their equal term, and take our restriction on close 0 to pi, okay, and then try to apply the concept, and we will get the easy solution, okay. So now let's get started our today's solution. I will explain to you all each and every step in detail because of the question it is from JEE Advanced. In my solution, we have given a matrix M sin 4 theta, negative 1 negative sin square theta, 1 plus cos square theta, and cos 4 theta, which is equal to alpha I plus beta m inverse, okay. So this is the value for M, where alpha is equal to alpha of theta, beta is equal to beta of theta. Both are real numbers, okay. Identity 2 by 2 matrix given, alpha star given, minimum value for that certain interval, and beta star it is also given here, okay. And by using all the data, we want the value for alpha star plus beta star, okay. Now observe here, we have given M matrix, okay, which is alpha I plus beta M inverse, okay. So it can it seems like that M inverse is given, okay. So M inverse means we have to find out the inverse of M matrix. So once we get the inverse of M matrix, apply the identity matrix and try to figure out the value for alpha and beta, okay. So here in our next step, we have matrix M. So why we have to find out the determinant of M? Because we want the inverse of M. For finding the inverse of M, we need a determinant of M. Why? Because M inverse is equal to 1 upon determinant of M into adjoint of M, okay. There are some certain other way to find out the inverse of a given matrix, okay, like a cofactor minor way, like a reduction method, inversion method. That way you may go through finding their values, okay. So it is not that difficult, but I feel that for 2 by 2 matrix, this is the easiest way. We will get the inverse of a matrix in a short time, okay. So by using this method, try to find out the inverse, okay. So for that we need a determinant of A and adjoint of M, okay. So determinant of M, just go through the similar regular process to find out the determinant. This into this minus this into this, okay. So sin 4 theta into cos 4 theta minus negative of 1 sin square theta into 1 plus cos square theta, okay. Their multiplication here and subtraction between them, okay. So it is here as it is. So take negative sign under bracket, we will get here negative 1, or take negative 1 from this bracket outside. So 1 plus sin square theta, so negative and negative we will get the positive here, okay. So under bracket 1 plus sin square theta, 1 plus cos square theta, okay. So sin raised to 4 theta, cos raised to 4 theta as it is, multiply these two bracket, first term into 1, 1, first term into cos square theta, again sine square into 1 sine square theta sine square into cos square theta, it is here. Okay, so sine square theta plus cos square theta is a 1 plus 1, it is a 2. Sine square theta into cos square theta as it is here, sine 4 theta cos 4 theta as it is here. Okay, because this is the multiplication both of these terms here. Okay, so I got the determinant of m. So these are the quite look like a trigonometry complicated terms. Okay, but once we solve some certain some more step, we'll get the some short type of the answer. So don't worry about it, just go find the next step only. So here determinant of m, it is here. Now let's find out the inverse. Okay, m inverse is equal to 1 upon determinant of m into adjoint of m. So I got the value for determinant of m. But now how to find the adjoint? Okay, as we learn in a matrix and determinant chapter, for finding adjoint we use minor and cofactor. First of all, we find the minor, then we go for the cofactor as a minus 1 raised to I plus j into minor of mij. Okay, so this is the way to find out the adjoint of a matrix. Okay, and then inverse. So for finding these terms, it is quite bit time taking or lengthy. So I have one short trick here to find out the adjoint for 2 by 2 matrix. So for finding the adjoint of a 2 by 2 matrix, what we do? We replace these two values. So sine raised to 4 theta goes to cos raised to 4 theta, cos raised to 4 theta goes to sine raised to 4 theta. Okay, so we interchange their places here for first 1 1 2 2 value. So replace their places, and remaining two terms here give the negative sign here and here. So negative 1 negative cos square theta, negative negative 1 positive 1, negative negative sine square theta is a positive sine square theta. So this is the easiest way to find out the adjoint of any matrix. Okay, so I'm gonna apply these steps here to our solution. Okay, 1 upon determinant of a. So adjoint, replace their place. So sine 4 theta it is here, cos 4 theta it is here. Apply negative sign, negative 1, it is positive 1, negative negative sine square theta, positive sine square theta, negative 1 negative cos square theta. Okay, so I got the m inverse here. Now in our question we have given m which is equal to alpha I plus beta into m inverse. So this one is a given, in our question. Okay, this step. So substitute the value, and identity, we have identity is a 2 by 2 matrix. Okay, like 1 0 0 1, this is a 2 by 2 matrix identity. So identity is here 2 by 2 matrix, and now we want the identity into I. Okay, so that means alpha into I. Okay, 1 0 0 1. So how can we write identity as a alpha multiply under bracket alpha into 0 0, alpha into 0 0 and 0. Okay, so alpha I can be written as alpha 0 0 alpha. Okay, so this one I written here. Okay, don't get confused, just a scalar multiplication of matrix here. So beta into, okay, so m it is here, alpha I it is here, beta as it is here, m inverse 1 upon determinant of m, and this matrix as it is here. Okay, now we want the value for m alpha beta. Okay, so for finding the alpha and beta we need to know, so it is possible to compare, okay, corresponding element in our matrix. Okay, so how we compare the corresponding element in a matrix? Okay, so if we have x y z 1, okay, and 5 4 3 l. Okay, so we compare corresponding element like x which is equal to 5, y which is equal to 4, z is equal to 3, and 1 which is equal to l. Okay, so this is the way to compare corresponding element from our matrix. Okay, so now we want the value for alpha, so we can write alpha plus beta by determinant of m into cos square theta, which is equal to first corresponding value sine raised to 4 theta. So first corresponding here with the first corresponding here with the first corresponding. So alpha plus beta by determinant of m into cos raised to 4 theta, which is equal to sine raised to 4 theta. Okay, now similarly we have possible chances to compare here too. Okay, so compare this one, because 0 we cannot compare 0 because there is no value of alpha beta do exist. Okay, so you may go through the comparing of 0 also, you will get the other value too. Okay, now in my next step what I have done, I compare this 1 plus cos square theta into this 0 plus beta into modulus of m is equal to minus 1 into cos square theta. Okay, so if alpha getting 0, then you will get the value for beta. Okay, so beta by modulus of m minus 1 minus cos square theta, negative common here, so 1 plus cos square theta, which is equal to this compared with this one. Okay, 1 plus cos square theta. Okay, now so take this term here, so negative it is goes to downside, these two terms similar get cancelled, so beta by modulus of m is a determinant of m is a negative of 1. Okay, so that means I got the value for beta which is a negative of a determinant of m. Okay, So we do not have any some certain type of constant value like this. Okay, so we have to assume x y like this value as a beta. Okay, so beta I got the value for beta, it is here as a negative of em. Okay, so this is the step which is coming from here. I hope you all have understood till beta. Okay, now let's move to find out the value for beta and the value for alpha. Okay, so by using this it is easier to find out the alpha and beta. Okay, so because beta by modulus of m is a negative one, so substitute it is here. So alpha is equal to sine raised to 4 theta, that it goes to plus cos raised to 4 theta. So we will get the value for, so alpha is the sine raised to 4 theta plus cos raised to 4 theta, and beta is a negative of m. So substitute here, beta is a negative of m, it is here. Okay, so now let's get to our next step. So by using this, I substitute beta by modulus m as a negative 1 in our equation of alpha. So alpha plus negative of 1 is a cos raised to 4 theta, which is equal to sine raised to 4 theta. Okay, so I got the value for alpha is a sine 4 theta plus cos 4 theta, and beta is a modulus of a negative m. Okay, so substitute the value for determinant of m, it is here, not a modulus. Okay, this one is a determinant. Okay, so beta is equal to negative of determinant of m. We found earlier this value for determinant of m. Okay, so now let's work out for the value for alpha. Okay, so sine square theta plus cos square theta. So try to sine 4 theta plus cos 4 theta, because this term it is quite much bigger power. Okay, so try to reduce into the some smaller power. So we have possible chances to take their square or take their square root. Okay, now I written this one is a sine raised to 4 theta is a sine square theta to the power 2. Okay, that means we add their power if power is there. Okay, so sine 4 theta can be written as sine square theta to the power 2, cos 4 theta can be written as cos square theta to the power 2. So what I have done, just to take their power in some short form, so I added here 2 sine square theta cos square theta. But why I added here? Because we know that a square plus b square plus 2 times ab. So 2 times ab is not there, so 2 times a into b add there, and as well as if you are adding, subtract also. So our original term remains same. So 2 sine square theta cos square theta minus 2 sine square theta plus cos square theta, it gives value 0. That's why I added and subtracted. Okay, now a square plus b square plus 2 times eb, which is the square of a plus b bracket square, and remaining term as it is here. Okay, so sine square theta plus cos square theta, the value it is coming 1, and 1 square is 1. So negative over 2 sine square theta cos square theta, it is here. Okay, so I got the value for alpha is 1 minus 2 sine square theta cos square theta. So it is involvement of a sine theta and a cos theta too. Okay, but in our question we have given the sine alpha which is having minimum value and beta which is also having minimum value. Okay, for some certain theta. So we want our equation in the form of a sine theta or cos theta. Okay, so we cannot substitute directly the minimum value here. So if you're going to substitute, then it is again goes to the little complicated step. So to avoid these steps, what we have to do, we have to transfer our sine cos into either sine or whether it is in the cos. Okay, so for that I use here sine 2 theta. Okay, for that term I use here sine 2 theta is equal to 2 sine theta cos theta, just to substitute this value only, 2 sine theta cos theta. Okay, sine 2 theta. So divide what we have here, sine 2 theta, we want the 2 sine theta cos theta. Okay, 2 sine theta cos theta is already there, take the square for theta here, here square, here square. Okay, so sine square 2 theta is equal to 2 square is a 4, sine square theta is equal to cos square theta. What I have done, I just taken square from all the sides and multiplied 1 by 2 to the both side. Okay, take the square and multiply 1 by 2. After taking square, sine square 2 theta, 2 square is a 4, sine square theta and cos square theta, and 1 by 2 multiplied here. So our original term will remain same. So 1 by 2 sine square 2 theta can be written as 1 by 2 multiplied by 4. So it comes to sine square theta cos square theta. Now we can see it here. 2 sine square theta cos square theta, I got it is 2 sine square theta cos square theta. Okay, which is 1 by 2 sine square 2 theta. Okay, so this is the value I got it here for 2 sine square theta cos square theta. So substitute this value again back here. So I got the value for alpha. So I got the value for alpha, which is a 1 minus 1 by 2 sine square 2 theta. Okay, so this is the value for alpha. Now this is the right time to substitute the value for sine square 2 theta. Okay, so we know that theta is having some restriction for alpha. Okay, so it is, we have to take the theta from close 0 to open interval 2 pi. Okay, so 2 pi it is not there, always remember. Okay, so we want the minimum value for this certain term. Okay, so we know that for sine square 2 theta under close interval 0 open interval 2 pi. Okay, sine which is having minimum value at a pi, okay, which is a negative 1. So minimum value for a sine it is a -1 and cos it is a -1 and maximum value is 1. Or minimum positive value if we want, then we will get the more than 0. If 0 it is not coming, then 1 by root 2 is the minimum value, positive minimum value for sine and cos. Okay. So for positive minimum value, you may go through the value for pi by 6 directly, which gives a 1 by root 2. It is a smaller value. Okay. So we know that sine and cos will always gives us value 0, 1 by 2, 1 by root 2, root 3 by 2, 1 and minus 1. Okay. So maximum value is a 1. Smallest one value is a -1. Then bigger than value is a 0. And after that, so little bigger 1 by root 2. Then more bigger root 3 by 2, and after little no more bigger 1 by 2 and root 3 by 2, and at the end 1 is bigger. Okay. So -1 we write it as a -1 is smaller, then 0 is little bigger, then we write 1 by root 2 is little bigger, 1 by 2 bigger, then root 3 by 2 bigger, and 1 is bigger. Why I'm explaining this quantity here? Because we want the minimum value. This is the application based part. We have to apply to get the minimum value for sine 2 theta. Okay, or cos 2 theta also. So this value you need to know. So our minimum positive value, it gives up 1 by root 2, and 1 by root 2 value which goes for sine, which is a pi by 3, and a cos which is a pi by 6. Okay, cos gives a pi by 6 as a minimum value, and sine gives a pi by 3 as a minimum value, positive non-zero minimum value. Okay, and the only minimum value which is a -1. Okay, so under open interval 0 to 2 pi, okay, close 0 open to pi, sine has a minimum value at a pi is a -1. Okay, pi at a -1. So that means we want the value for sine 2 theta. Okay, sine 2 theta. If you know sine 2 theta, then later on find out sine square 2 theta. Okay, first of all find out sine 2 theta. For finding sine 2 theta, so we know that the minimum value for sine, which is gives a -1. Okay, so -1 for sine 2 theta. So we know that at a pi, sine give negative value. Okay, which is a -1. Okay, at a value of a pi. But non-zero positive value if we want, then sine only is having non-zero positive value and smallest value, which is 1 by root 2. Okay, which is only the non-zero, as I explained here, non-zero positive value for 1 by root 2. It is given in our question. Okay, non-zero positive value, it is here 1 by root 2. Okay, so sine pi by 4, sine pi by 4 gives, sine pi by 4 gives value 1 by root 2. Okay, and cos similarly cos pi by 4. So it is not a pi by 3, okay, or pi by 6. It is a pi by 4 value that I explained here. The sine which is having smallest positive value is a pi by 4, and similarly for cos it is a pi by 4. Okay, so which is a 1 by root 2. So if I consider as a sine smallest positive value as a pi by 4. Okay, so if it is a pi by 4, gives sine gives the smallest value at a pi by 4. Okay, that means it is a 45 degree. Okay, so at a sine gives a value, smallest positive value at a theta is a pi by 4, but we want the sine 2 theta, not a sine theta only. Okay, so sine 2 theta means sine 2 pi by 4, which is equal to sine 2 pi by 4. We want 2 ones are 2, 2 twos are 4. That means we want the value for sine pi by 2. Okay, here we want the value for sine pi by 2. Don't get confused. We want the value for sine 2 theta. Sine pi by 4 gives a 1 by root 2 value, 1 by root 2 value, which is the smallest non-zero positive value. But we want the sine 2 theta, so sine 2 pi by 4, which is a sine pi by 2. And what is the value for sine pi by 2? Sine pi by 2 is 1, and sine pi by 2 is -1. Okay, so it gives 1. And sine square 2 pi by 4 means 2 theta. Sine square 2 theta is 1 square means 1. Okay, so we will get the value for it is a 1. Okay, so 1 minus 1 by 2 into sine square 2 theta, we will get the sine square 2 theta is 1. Okay, so 1 minus 1 by 2, I got the value for alpha is a 1 by 2. Okay, because of we have given minimum condition for minimum value of a theta. Okay, that's why it is quite a bit lengthy to understand. Okay, so now let's get to start the value for beta. Okay, I hope you all have understood the minimum value for alpha. Okay, sine, which gives the value alpha 1 by 2. Okay, so minimum value non-zero positive you have to consider here. Okay, as a pi by 4, and we will get the alpha as a 1 by 2. Now let's get to start the value for beta. So here the value for beta, we have negative of a determinant of m. I written over here. Okay, negative into determinant of m, it is here. So negative as it is, 2 as it is. Sine square 2 theta cos square 2 theta plus sine raised to 4 2 theta cos raised to 4 2 theta. So we have to find out the value for beta. Okay, so as we know that for cos square 2 theta, in our determinant we have only theta. Okay, so I multiplied 2 theta to every theta, so it doesn't affect our solution. That's why I multiplied 2 theta everywhere. Similarly, you will get the value for cos square theta. Minimum value you have to find similar like we did here for sine square 2 theta. Okay, so sine square 2 theta is a cos 2 theta having a minimum value 1 by 2, then its square is 1 by 2 bracket square. Sine square 2 theta is here. Cos raised to, now here it is a 4. So sine raised to 4 2 theta as it is here, cos raised to 4 2 theta, that means it is 1 by 2. Cos 2 theta is 1 by 2. Cos raised to 4 2 theta is 1 by 2 bracket raised to 4. Okay, so negative 2 as it is, 1 by 2 square is a, so negative 2 as it is, 1 by 2 square is 1 by 4. The sine 2 theta, it is having minimum value is 1. Okay, earlier I explained here, it is a 1. So multiplied by 1, 1 upon 4 is 1 by 2 raised to 4 is 1 by 16, and it is multiplied by 1. So solve this one, so you will get the negative of 37 by 16. Okay, just go for the addition of these three terms. So it is the negative 37 by 16. So this is the value for beta star. Okay, so I got the alpha star, which is a 1 by 2, and beta star is a negative 30 by 7. Add them, alpha star plus beta star. Alpha star 1 by 2 plus beta star 37 by 16. Their subtraction, we will get the negative of 29 by 16. Okay, so this is the option number D, which is correct in our question. Okay, so I hope so you all have understood my today's solution. It is completely based on determinant and trigonometry part of mathematics. Okay, so nothing is difficult, just need to apply some application based question. So you need to understand only the minimum part of our question. Okay, so thank you everyone, thank you for my today's lecture. I hope you all have understood my today's solution. So if you have any doubt, difficulty, let me know in my comment section. Okay, thank you everyone.